Hi everybody, and welcome to exercise 3 on page 59 of the workbook. This is a two-part problem involving account balances. Let's take a minute just to read part A together. So they're telling us if we invest $10,000 in a bank account at an annual interest rate of 5%, then after T years we will have B dollars, where B is given by the formula to the right. Okay, B of T is 10,000 times 1.05 to the T. And they would like us to find B prime of 5 and then to interpret that number in context here. All right, so let's start by calculating the derivative here. Okay, so B prime of T. Looking at this formula, notice that we've got a 10,000 out in front that's constant. So that constant's going to kind of come along for the ride. And what we really need to take the derivative of then is the 1.05 to the T part. Okay, and you might recognize that as a function that we know how to take the derivative of. It goes back to the formula for the derivative of an exponential function. Okay, a constant raised to the x power, we can find its derivative by using the formula d dx of a to the x is a to the x ln of a. In our case, the a is just that number 1.05. Okay, so if we apply that formula, we are going to get 1.05 to the t, natural log of 1.05. Okay, there's our derivative. And we are interested in the derivative at a particular point, t equals 5, as it turns out. So let's go ahead and substitute t equals 5 in here and see what we get for a numerical answer. Okay, and at this point, that's a job for your calculator. You can punch that in and confirm that you get an answer of about 622.7. Okay, now what does that number mean that we just calculated? Well, as we've done before, it's a good idea to think about units when you're trying to interpret something like this. So let's think about this function b of t that they're giving us. They didn't give us a graph, but we can kind of think about what a graph would look like. Okay, so we've got, let's see, two variables involved. T is our input variable, and that was a time in years. And then B was our output variable representing the balance of our account in dollars. Okay, so this B prime of 5 down here, then that is a derivative. And so its unit should be dollars per year because it represents a slope. So we're thinking rise over run. And by knowing those units, it gives us some insight into the meaning of this calculation that we did. Dollars per year represents how fast the balance of our account is growing, okay, as time goes by here. Okay, so in our interpretation, let's start by just kind of writing down the introductory information that they gave us. So this means that $10,000 at an interest rate Now we're ready to talk about the derivative. So we're getting an account balance increase of $622.7 per year. Okay, we'll try to write that into our explanation. Okay, you can expect to grow at a rate of $622.70 per year. And then the only missing piece is, what about this 5 here? What does that represent? Remember that that's a time. And so it's kind of giving us the time at which we're measuring this rate of change. So we might just add at t equals 5 years to the end of this explanation. Okay, there's in words what this derivative that we calculated is representing. Okay, so we are ready then for part B. And this is a new question. It's still about account balances, but it changes the perspective a little bit here. Let's read this second part together. So if you invest $10,000 in a bank account at an annual interest rate of R%, then after 10 years you will have B dollars, where B is given by the formula to the right. Okay, B of R is 10,000 times 1 plus 0.01 R to the 10. And again, they want us to find B prime of 5. Notice, though, that this function is a little bit different. It's giving us account balance as a function of the interest rate. Okay, assuming that we're investing money for 10 years, we want to compare our account balance that we would have at various interest rates. Okay, so let's see if we can calculate the derivative here. All right, so this time our formula is sitting over here. So we've got a 10,000 in front again. Okay, that's a constant that's going to come along for the ride. And what we need to take the derivative of then is this 1 plus 0.01 r to the 10th. Notice that that's a chain rule situation. Okay, we've got 1 plus 0.01 r raised to the 10th power. So if we take the derivative of the whole function u to the 10th, we're going to get 10u to the 9th by the power rule. Okay, and then we need to multiply by the derivative of the u. What is the derivative of 1 plus 0.01 r? We're just going to get 0.01 out of that. Okay, the 1 at the beginning goes away, and the derivative of the r is 1. Okay, we'll maybe go one more step here and simplify this a little bit. I think that'll make this easier. So if we do some consolidating, okay, we've played this game before. We've got 10,000 times 10. That's going to give us 100,000. But if you take that 100,000 and multiply by 0.01, that's going to collapse down to one number of 1,000. It just makes this a little bit easier to work with. Okay, and again, they would like the value of the derivative at a specific number of 5. Let's go ahead and substitute that in. Whoops. Okay, and I'm going to go ahead and get a number for that. You can punch this into your calculator and confirm that you will get about 1551.33 out of that. Okay, and again, they would like us to interpret this. All right, so let's think about units here. What would the units on this number be that we just calculated? Okay, well, let's think about this graphically again. So this time, our function has an input of r. R is representing interest rate in percent, and B is our output variable. That's, again, our account balance in dollars. This time, the units then are going to be dollars per percent, rise over run. Okay, that's kind of a strange unit. What is it really saying? Okay, well, if you think about it, it's representing how fast our account balance is increasing as the interest rate increases. So for each percentage point that we increase the interest rate by, we're getting this amount of increase basically in our account balance. All right, so let's see if we can give an interpretation of this then. Okay, so this means if you decide to invest $10,000, that's our starting amount again, okay, in a bank account and leave it there for 10 years, okay, that number's staying constant. Okay, and then we come to this number. Okay, what's the meaning of that number in this case? Okay, that's our input variable is r in this case, so that's representing a percent in this case. So we could add that to our explanation by saying at an annual interest rate, okay, and now we come to the rate of change part. Okay, here we can expect our earnings to increase by about $1551.33 per percent increase in the interest rate. Let's write that into our explanation here. Okay, and I think we have a complete explanation here.